Chapter 9 is gonna teach us how to do some counting and probability. So if you haven't read the section in the book, I would highly recommend that you stop the video and read the relevant pages in the book so that you can kind of get an idea of what we're gonna be doing here and why this is relevant. The book talks about different reasons why we need to have an established weight for counting. Here's another example that I created. If I said my classroom is in the first floor, what would you understand? Well, in the United States, you would understand that you're on the ground level, but in other places in the world, they would understand that you're not on the ground level, but one level above. So, things like that can be misinterpreted. So this is the reason why we care about probability and counting, okay? So a couple of terms before we get started, a few definitions so we can get going. We will say that a process is random when it means that when an event takes place, one outcome from some set of outcomes is sure to occur, but is impossible to predict which one it's gonna be. So basically, think of it like flipping a coin. You know it's gonna be either heads or tails at the end, but you cannot predict which one it's gonna be ahead of the experiment. So that's a process that we call random in math. Okay. A couple other terms. Sample space is the set of all possible outcomes of a random process. So in my example about the coin toss, the sample space would be heads or tails. Those are the possible things that could happen when you run the experiment. So we call them the sample space. An event is a subset of the sample space. So getting heads is basically event, or getting tails is an event. So it's one of those two. Okay. The probability, there's a definition right there. Go ahead and read it. There's going to be different kinds of probabilities that we deal with in life, but we're going to be focusing on classical probability. Basically, it's calculated with this formula that we have right here. The probability of an event E is the number of outcomes in E divided by the total numbers in the total number of outcomes in the sample space, basically. So, like for example, if I want to know what's the probability of getting tails in my coin flip game, there's only one way to get tails, and there are two things in the sample space. So basically this is going to be 0.5. So another way of saying that is to say 50%. It's 50% likely that I'm going to get tails when I flip a coin, and again, if I do the same experiment, it's 50% likely that I'm going to get heads. Okay, so that's what we call the probability, equally likely probability formula. When we're talking about sets, it's useful to know about cardinality. Cardinality is basically the size of the set. So if I tell you here's a set with 1, 4, 5, and 6 in it, what's the cardinality of this? The cardinality would be, if I call it A, for instance, I would call it n of A, or sometimes people use the absolute value symbols. This would be how many elements there are inside here. So 1, 2, 3, 4. Okay. Now, if you had one, let's say, duplicated, then we only count it once. So it still is 4, basically. Okay. So that's cardinality. And then finally, let's talk about card games, which we're going to be using in a few examples. Decks of cards. The standard decks of cards have 52 cards, and there are 4 groups called suits. There are 2 red suits, the diamonds and the hearts, and there are 2 black suits, the spades and the clubs. And each of the cards have a denomination. They have a number basically, or a picture on it, and the numbers go from 2 to 10. Then you've got the jack, the queen, the king, and the ace. And these 3, jack, queen, and king, they have pictures, so they're called normally face cards. Okay, so all this stuff should be kind of sort of familiar if you've played cards, but let's talk about some probability at this point. Okay, so we're gonna discuss some probability and statistics and counting basically. So here's the first example. Given an ordinary deck of cards, so the same one that we just described over here with the 52 cards and everything, what's the event that a chosen card has a black face? Okay, so we want to first describe what the event looks like, then we want to find the probability that this event happens. So what does the event look like? So the event is going to be chosen card has a black face. So chosen card has a black face. Well, the set looks like this. I could get pretty much a jack or a queen or a king of diamonds and spades and clubs. Okay, so clubs and clubs again. Or I could get a jack, a queen, a king of spades. So I'm gonna try to make a spade symbol. And there you go. So those are the possible ways to get a card with a black face. Okay. No other cards would have the color black and would have a face on them. Okay. These are the only ones. So now what's the probability? What's the probability that the chosen card has a black face? So remember how this works. It's going to be some sort of a fraction. And so here we go, fraction. And it's going to count how many possible outcomes are in this event, which is 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes divided by the total number of outcomes in the whole game. So how many possible outcomes are in the game? Well, you can have 2, 3, 4, 5, 6, 7, 10, whatever. Jack, queen, king, ace, and so on. And they could come from any of the suits. So that means there are actually 52 possible outcomes. And 6 divided by 52, we'll just put in a calculator, and the answer is gonna be 0.11 and then 538. So commonly in these problems, we will round to 4 decimal places. So it's gonna be 54. The reason why we do that, because sometimes we like to turn this into a percentage, and we want to have 2 decimal place accuracy when it's a percentage. So that's the reason why we usually pick 4 decimals, okay? Now, what's the probability that a card at random has a red face? Well, I mean, it's expected to be the same as the probability of having a black face, because everything is pretty much symmetrical in this game. What I mean by that is there are 2 suits of black, there are 2 suits of red, and the cards pretty much all have the same denomination everywhere, whether you're red or black, okay? So that's the reason why the answer is the same, okay? What's the probability that a card picked at random has a denomination of 3? Okay, so let me describe first the event. So the event, I want denomination of 3. So I want the number to say 3. So card number, let's say card number is 3. Well, I could have that by getting the 2, 3 in red and the 2 3s in black. No other cards would have 3. So how many was that? That was 4 of them. Okay, so now the probability that the chosen card has number 3, it's going to be 4 divided by 52 possible outcomes in this game. Okay, so again, with the calculator's help, we can get the solution. So the solution is going to be 0.0769. So rounding it to 4 decimal places, because if I turn to percentage, I'll have 2 decimal place accuracy. Okay, so let's take a look at the probability that a card picked at random is black and has an even number on it. So let me start by first describing the event. Okay, so the probability, in order to get the probability, I need to know what the event looks like first. So what's the probability, or what's the event gonna look like? Well, first, there are the 2, 4, 6, 8, and 10 of spades. And finally, there are the same cards, the 2, the 4, the 6, the 8, the 10 of the clubs. So in total, there are 10 cards. So what's the probability of the chosen card being black and even? Well, in this case, it's going to be the number of cards, which is 10, divided by the total number of cards in the game, which is 52 again. That tallies up to 19.23%. Perfect. Next, we have the question: what's the probability that a card picked at random is at most 5? And in this case, they want us to count aces as high. So in other terms, don't think of ace as a 1. Think of it as, like, the highest number in the game. So let's see. We want the card to be chosen at random to have at most 5. So that means the card could be 2, a 3, or a 4, or a 5, and it could come from any suit. So this is the description of the event. You could have 2, 3, 4, 5 of diamonds, hearts, spades, or clubs. So now the probability of the chosen card being at most 5 is 16 divided by 52, because there are 16 cards in this possible event space, and so now 16 divided by 52 is going to be 0.30 and then 77, which is pretty much 30.77%.